Hello everyone and welcome to the third part of this tutorial series. In this one we'll continue from where we left off. So in the previous video we connected our application to the Redux store over here, and we saw part of the we saw the benefits of connecting our application to the Redux store. Now the next part would be doing in this tutorial would be trying to get the user data from the online API over here, just like how we did in the first video. So now the next question would be, where do this code go into? But before that, I want to show you something. So this is just the basic flow of a React Redux application, and this diagram could look familiar to you if you followed the previous video. So now a breakdown of this diagram would be a component dispatches an action, the action reaches the reducer, and the reducer checks the action type and the data. Then what does it do? It updates the store. The reason why the reducer is in between the action and the store is that the reducer is the only function or the only item that can actually update your Redux store. So when the store is updated, any connected components would receive the store data as props using the connect function. So this is just a basic flow of a React Redux application. So now the question would be, where do we put the code for fetching the API request? Where do we put the code that gets this API request and displays it in the navbar and the footer? So first of all, before we do this, we have to understand the rules that are with Redux. So over here, should we put it in the component? We can't be able to put it in the component, because if we put it in the component, it's still the same way like we did previously. But we want to manage this type of asynchronous request with Redux. So it has to fall in line with, we have to put it somewhere in the Redux architecture. So we can't do it in the component, and we can't do it in the action, because an action is just simply an object that has the type property and an optional payload property or a data property. Now the next option of where we could actually put this would be the reducer, right? But not really. We can't do that in the reducer. And the reason is very simple. Part of the rules of Redux is that your reducer should be a pure function. So over here, if you look at the reducer, the rule states that this function over here, this reducer function, should be a pure function. So what is a pure function, first of all? So they are different. I could write it down quickly, then I'll show you an example. So the reason I'm doing this is for us to be able to see why we can't actually put this stuff in your reducer. So a pure function must return the same outputs on the same inputs. So what that simply means is, I could show you an example quickly. So this could be a pure function. Add takes in x, y. And I'll also talk about the benefits of why the Redux team decided to make reducers pure function. So if you do this, return x plus y, then over here we'll call add, we say 5 and 2. If we run this, the result would always be 7, no matter how many times we run this. So this add function over here is a very good example of a pure function. But if we do something like this, if we change this function to become this, return math.random plus y, then we pass into. So when I run this, can you see the value here is 2.21. I passed in the same input, which is y, and as in which is 2 over here. So if I run this again, can you see, look, it's now 2.22, which means add is no longer a pure function. And from the rule I stated here, I said that must return the same output on the same input. So you can see the add function does not return the same output on the same input. I passed in 2 here and I ran, and if I run it, it returns a different output. So one of the reasons behind this is that why your reducer function should be pure is for predictability and also testability. So what that simply means is that whenever I pass in the state over here, whenever I pass in the channel name, whenever I pass in channel name to be flying hawk, or let me say to be flying dodo over here, and I click update channel, I need to expect the current state of the channel name to be flying dodo over here. So if that reducer function probably made use of a additional probably math.random and added an ID here, I wouldn't be able to predict my state. So if I were to write a test for my reducer, I wouldn't be able to predict that if I enter flying dodo, the current state of channel name should be flying dodo. So that's one of the reasons why your reducer function should be pure. So whenever you are testing, you should expect the correct output. Another feature of a pure function is that a pure function must not mutate. Must not have side effects. So what are side effects? Examples of side effects could be something like network call, write to file. These are just login to screen or printing to screen, whichever one. So basically what a side effect is, a side effect are just like state changes that could be tracked or could be observed outside this function. So for instance, now if we wanted to make that fetch request inside this reducer, if for instance we wanted to make a network call to the reducer, when we execute that network call to the reducer in the reducer, our browser could be able to track the network request over here in the network tab. Our browser could be able to track that request, and a pure function should not be able to do this. One of the reasons why you should not be able to do something like this is because this network call could be an asynchronous code. And one thing about asynchronous code is that they could lead to race conditions. So for instance, now if inside my reducer I were to put the fetch request here that would click when I click the button, then inside here I could now make a HTTP fetch request. The question would be, what if I clicked on this button twice? Or if it was a button that was getting the current logged in user, what if I click these buttons like very quickly, like 5 times? What will happen would be 5 requests to be sent, 5 requests to be sent at the same time, and this request would run concurrently. So now the question would be, which of that particular 5 requests would update my Redux store? So having this type of scenario whereby you put asynchronous code inside your reducer and you click this button multiple times, it could lead to race conditions. So race conditions could be a scenario whereby you have multiple requests and you cannot really track the particular one that will resolve. So if you click the button 5 times and the 5th request was faster, it would update your store, and that might not be the actual thing you actually want. So you should not your reducer functions should not have side effects inside them. There are lots of features of pure functions. One other one would be, let me just put it down. Pure functions should not mutate external states. And we've already done this. So over here, if you remember this example I did here, I said that we had to like update the state immutably. So if this reducer function did not update the states mutably, we saw the example whereby I just kind of like overrode the previous states with this channel name. So if you mutate external states, other parts of your program, other parts of your application could be making use of this particular state. So if you just change that state directly, it could cause havoc, because you'd have to start trying to kind of like track every single thing that happens. The example I gave you guys here, whereby I did not, okay, if you watch the previous video, you'd be able to see it. If I did not update this state mutably and I just replaced channel name over here, the app component made use of this username, and what happened? It's deleted it, it's replaced it. So that's kind of like mutating the state. But a pure function should change any data immutably, which means you kind of like cloning the previous data and only updating the part you want. So that is just a basic walkthrough of what pure functions are. And if you come over here to the diagram, so since we are not going to be able to do it in the component, we can't do it in the action because the action is just an object. We can't do it in the store because the store just contains your states, and we can't do it in the reducer because the reducer has to be a pure function according to Redux. So now the question would be, where do you actually perform these side effects? Where do you actually perform these network calls? How do you go about this? So Redux provides us with something called middlewares. So middlewares, if you've done a little bit of backend programming like Express.js or Django, you'd know the concept of middlewares. So for a backend application, a middleware is just in between your request and your response. So whenever a user makes a request on your web application, a middleware is just in between that request and response. A middleware could be for like authentication. So when a user makes a request, it's going to, the middleware in between will just check if this user is currently authenticated and know the type of response to send back to the client or to the user. So for a Redux application, a middleware is going to be in between your action and your reducer. And the reason being that if your middleware is kind of like in between this area, it means that whenever I dispatch an action, the middleware will take that action and do some certain stuff, then sends a new action to the reducer, or that middleware could also produce a result. So for instance, now, if we create a middleware or if we implement a middleware in between the action and the reducer, so if I dispatch an action called fetch user, the middleware is going to take that fetch user action and do what? Perform a side effect. So it could be to like fetch the user from an online API. Then when that user has been successfully fetched from the online API, it should dispatch another action to show like, okay, probably fetched user successfully. So that action could have a payload that will be sent to the reducer, and the reducer could update the store accordingly. So the middleware in summary is just in between your action and the reducer, and you use it to handle asynchronous code. You can use it to log out stuff. You can use it to do so many things. But for this tutorial, we're just going to be focusing on how to make use of the middleware to perform asynchronous actions. Asynchronous action could be like fetching this online data. So the middleware we're going to be using in this tutorial is called Redux-Saga. So I'll show you an example of what that does. Okay, I'll save this and we'll create a new file called a saga or sagas.js. So like I said, a middleware is just in between your action and your reducer. It takes an action and performs an asynchronous request, then it sends a new action that gets to your reducer, and your store is updated accordingly. So now, one thing about this ReduxSaga over here. If I go to package.json, I've installed it previously. You can see it over here. I installed it previously. So ReduxSaga makes use of something called generators. So before we get into writing the code for ReduxSaga, I will just show you a basic example of generators. So when I start writing the code for the ReduxSaga, you'll be able to understand what I'm doing. So now, a basic function in your JavaScript, let me just quickly write this. So in JavaScript, a basic function, if I run this function, it runs from top to bottom. So in JavaScript, a basic function always executes from start to finish. The only way you can break out from a function is if you use something like a return statement, or you put you use something like a return statement. You could be able to terminate that function before it ends. And another way to terminate a function before it ends is if you throw an error. So you can see now we have this basic function that prints out these 3 lines: John, Kenny, and Tim. So there's something I'm going to show you right now, which I told you the ReduxSaga makes use of. It's called a generator function. So a generator function has the function keyword and this asterisk in front of it. So you're going to see, I'm going to explain what this does. So yield, I'm going to do the same thing: John, Kenny, and Tim. Kenny and so when I run this function, let's see, generates names. When I run this function, let's see what happens. So you can see something that just happened here. It returns an object, a generator object. Currently, this object is just showing empty. So a generator object is simply a type of iterator. So I can say iterator. I'll explain what happens here. So if I do a console, if I just type out iterator, let's see what happens. It does the same thing, but an iterator has a special method called next. So watch what happens. Can you see? So if you notice something, when I created this generate names, I made use of this keyword yield. I'm going to explain what that means. And it has 3 steps: John, Kenny, and Tim. Then I now created an instance of this function. I called this function and assigned it to this variable called iterator. So you can see iterator.next printed out John. So if I do that one more time, can you guess what it prints out? It prints out Kenny. When I do it the 3rd time, and watch, it has a value and it has this done property. So when I print it out the 3rd time, it prints out Tim, and the value of done is equals to false. Then when I print it the 4th time, the value is undefined and done is equals to true. So let me go back. So a normal function runs from start to finish without stopping or without breaking, unless you pass in a return statement or you throw an error. While a generator function has the ability to pause in between execution. So if you notice something, when I called this next function the 1st time, what happened? It printed out John. only. It did not print out John, Kenny, and Tim. So a generator function has the ability to pause and resume execution. So that's just a basic difference of a generator function and the normal function. So you might be asking, like, what is the use of this generator function? Why do I really need it? One would be, let me just show you something quickly. I could actually do this. Return Peter. So I could say, let me run this. And normally in your normal function, a return statement should always be kind of like the last statement in the function scope. But over here, I called return before the function ended. So I'm going to do iterator.next. It prints out John. If I do the next one, it prints out Kenny. Then if I do the third one, it prints out Peter, and done is equals to true. So if I print out this, it's going to be undefined and true. So for generators, you can be able to kind of like cancel execution before the function ends. So ReduxSaga makes use of this in a way. When I write the ReduxSaga code, you'll be able to see it. So with ReduxSaga and generators, you can be able to like go through different actions, execute actions based on some condition, terminate actions in between requests and all this. So one of the reasons why ReduxSaga makes use of generators is because you can be able to cancel operations. So when you see the code, I think some of you would be able to compare it with async await, but I'll give you guys the differences why ReduxSaga does not make use of async await. One of the reasons is because you can't cancel promises, but with generators you can cancel your iteration. So one other thing, if you can see this word iterator, the generator works like an array, but it's not an array. They call it an iterable. So another way of transversing through this generator would be to use your for loop. I could just do that quickly. You could use your for off loop. So we pass in the iterator. This tutorial is not going to be focused on generators. I just want to show a brief intro, so when you see the code, it won't look so different. So for I could do console.log. I could print out I. And what can you see? It prints out John, Kenny, and Tim, just like an array. So an array is also an example of an iterable. A map is also an example of an iterable, kind of like a collection of items whereby you can transverse through. So you can see this function too is also, the generator function is also an iterable. You can see we kind of like looped through it, and we can be able to return it and cancel it. We can put that return keyword and be able to cancel the generator. So this is just the basic syntax of a generator. And you can see this yield keyword here. This yield keyword just shows that you should return that particular value and stop. That was why when we did iterator.next, it returns John and stopped. When we called iterator.next, it returned this Kenny and stopped. The same thing with Tim in the third line, it returns Tim and stopped. So what this for off loop kind of like does is that it goes through this generator function and it keeps calling the next function on each particular yield. So after each yield, it calls the next. After each yield, it calls the next. So that's how this for off loop actually works. So to do a brief recap once more, your normal function runs from top to bottom without stopping unless it encounters a return statement or it throws an error, while a generator function can be able to pause in between executions. So when I write the ReduxSaga code, you'll be able to see what I mean. So first things first, I would import something from ReduxSaga / effects. I'm going to explain what these effects are. So the first one I would import would be puts call puts take every and call. I'm going to explain what all this stuff does. So we'll create that function, the generator function. We'll put the asterisk. And what do we want to do? We want to fetch user. So fetch user saga. We can call it fetch user saga. So now what do I want to actually do here? I want to be able to perform some actions. So I could do const, and I'm going to make use of Axios. I'm not going to be using fetch. I'm going to be using Axios in this tutorial. No particular reason, but that's just what I'm using. So Axios.get, then I pass in the URL. Then I'll explain what this puts actually does. Then I'll do puts. So puts, you can see, create an effect description. So I'm going to be able, I'll explain what this effect does. So it's kind of like ReduxSaga version of dispatch. So when we were using Redux, we are dispatching actions. But over here, when you use ReduxSaga, you make use of puts effects. So it's going to kind of like dispatch an action to the middleware. I'll explain what this does. So now the action we're going to dispatch would be of type fetch user and it's going to have a payload of user should be equals to res.data. Okay, cool. So we have this fetch user saga, and the first line is just a typical Axios request. But when you're making use of ReduxSaga, you could do something like this. So normally for asynchronous code for promises, if you want to make it look synchronous, you have to make use of async await. But when you are making use of generators, you can just put this yield keyword in front of the asynchronous code. I'm going to go deeper and explain what that means. Then for the second line over here, we are making use of this put effects. So effects in ReduxSaga are just instructions you send to your middleware. So this put effect is an instruction which returns an object that tells your ReduxSaga that I want you to do what? Dispatch this action. So we're going to be talking about different effects as we go on. And one more thing to note is that this code should be put in your try-catch block, because it just kind of like looks like async await in a way. But I'll talk about the difference later on. So what I'm doing here, I want to get the user from this endpoint. Then I want to assign the user to this user data. So now this is if it is successful, I mean. So if it's unsuccessful, we put that in the catch block, and I put fetch user failed. So instead of user, I could just pass in error. I could pass in error this way. So this is a basic saga that does what? FET. That does what? Fetches the user from where this endpoint. So like I said, we're making use of effects, and I told you effects are just instructions we send to our middleware. In this case, the ReduxSaga is the middleware. So this puts effect over here, which I imported here. This puts effects. What it simply does it sends an instruction. Whenever the ReduxSaga sees a put instruction, it means that it should dispatch a particular action. So the action that it's being dispatched here is fetch user successfully. So for this second line, whenever this request fails, it should dispatch what? Fetch user failed action. So now the next thing would be, okay, we've done this first step. So this is the first saga. Then the second, this first saga is going to be the saga doing the work. While the second saga is going to be, you'd see it when I just quickly do that. Let me do that. Watch user saga. So it's going to be kind of like a watcher, and it's going to say take every what? Fetch user. I would explain what I'm doing. Flex user and okay. So cool. So now we have the worker saga and the watcher okay. And the watcher saga. So what this watcher saga actually does is that it watches. Whenever I dispatch the fetch user action, what should it do? It should call the fetch user saga. Now, this fetch user saga is the saga that does the real work. And what is that work? To get the data from the API and dispatch the actions depending on whether it is successfully or not successful. So, if you go back to this diagram over here, you can see I said the middleware is in between action and reducer. So this middleware over here is going to be the ReduxSaga. So whenever I dispatch fetch user action, that saga is going to take that action and try to get the data. If the data is successful, it dispatches the fetch user successful action, and that action goes to the reducer and the store is being updated accordingly. So that's just what we did here. So this middleware here is going to be in between the action and the reducer. So whenever I call on fetch user, I should do what? Call the fetch user saga, and this is the fetch user saga. So the first step it does is try to get the user asynchronously, and you know I explained why you can't be able to do that in your reducer. So this middleware does all the whole hard work, and if it gets the user successfully, what should happen? It should dispatch this action, and you know if this action is dispatched, it gets to the reducer and the reducer updates the store accordingly. So it's kind of like skips that whole asynchronous step in the reducer and also in the action. So the middleware handles all asynchronous logic. So now, since and if you can see, we made use of this yield keyword because of this is a generator function. So if I hover, you can see fetch user saga. It has 3 iterators. The first iterator is what? The promise. The second iterator is what? This puts effect. The third one is this puts effect for the error. And remember from the example I told you that iterators kind of like are collections. So you can see this fetch user saga it returns, if you see this mark, it returns 3 possible values. So it returns the promise, or this puts effect, which is to send the user to this reducer, or the error effect. So you can see it returns either the promise or the fetch user success action or the error action. Can you see it? It returns either this line or this line or this line. So for instance now, if the fetch user failed, if the user was fetched successfully, what should happen? It won't execute this code again. So the generator would break out. So that is just a basic explanation of this. So the next thing we'll be doing, or the next thing you'll be asking is, since we've created our middleware, how do we connect our middleware to our store? So to connect the middleware to the store, what we'll be able to do would be, or before that, let's try and handle these actions in our reducer. So the first one we'll be handling would be fetch user successfully. So over here, instead of us having this if-else statement, we could make use of what? A switch case statement over here, and to be action.type the first value would be update channel name, so I don't want to use this if statement, because if I use if statement, I'll be having multiple if-else statements. So the first one is update channel name. The second one is fetch user successfully. And what do we want to do here? We want to say the user, which is from this state over here. The user should be, so by default, the user, I would make it null for now. The user should be null. Then over here, I want the user should be action.payload.user. So this action.payload.user will be gotten from here, this value. So it's going to be, this is an action.thepayload.the-user. So it will have the user object over here. So that is the first step for that. Then the next one will be fetch user what? Field. Fetch user field. So we add one more property, which is the error. So by default, the error should be null. So by default, the error should be null. So I'm going to come here and say error should be action.payload.error. In the next video, we'll be able to make this, we'll structure our application better and reduce the boilerplate code. So by default, what should happen? I want to return the state if I don't dispatch any action. And the state is going to be the initial state. So we're going to remove this return statement. So this is how our reducer currently looks. So the first, so I'm just kind of checking the action type. So if it's update channel, do this. If it is fetch, if the type is fetch user successfully, do this. That means update the states with the user. If it is failed, update the error state with the error. Then by default, if I don't dispatch any action, what should I do? I just want to return the default state, which is this initial state over here. So now, and you can see there's really no need to implement fetch user, and I'll show you why. I'll explain why. So now we are done with the Saga, and we are also done with the reducer. The next question would be, how do we connect the middleware over here? Because the middleware is somewhere here. How do we connect the middleware to our store? So to do that is very simple. We just go to our store.js file. So instead of DevTools Enhancer, we're making use of Compose with DevTools Enhancer. So I'll just change this because we want to apply additional, we want to apply additional middlewares to our enhancer. So over here in Redux, I'll just import apply middleware. Then I'll import, I can just call it ReduxSaga from did I export it? Let me check. Store sagas, yeah, I did. So we just import user sagas, yeah. And the one we're going to be using is just this watcher. we'll just be making use of the watcher. So the watcher is just simply going to call this fetch user saga. So we don't need to export this. So whenever the fetch user action is dispatched, this function would be executed. So if I come over here, we have the user saga. Then inside here, I'll apply the middleware. So which middleware am I going to apply? We have to import it over here. So we'll do import create saga middleware. Cool. So now we create the middleware by, we could just name it saga middleware. It should be equals to create saga middleware. Cool. Then inside this apply middleware, we just pass the saga middleware. So this is how to apply middlewares to your Redux stores. So now what's the next thing to do? Once we've applied this saga middleware to our Redux store, the next question will be, okay, how do we know when we dispatch this fetch user? How are we going to make use of this stuff? So that's very simple. We just have to run the middleware. So the middleware is going to be running whenever our application is currently running. So I'm going to do saga middleware.run. And I'll pass in the user saga. Because if I hover over here, you can see, where is it? Okay, so we're passing the saga we want to run, and the saga we want to run is this user saga. It's going to be watching for whenever we dispatch this fetch user action, and it will call that saga above. So let's check if it worked. Then I'll come back and do more explanation. So we're having errors already. Okay, so user.state.name in our app.js, and the reason is very simple. It's currently saying cannot read property name of null, and the reason is very simple. Over here in our reducer.js file, I made the user property to be null by default. So for now, I'll just comment this stuff out because I don't want to use it there yet. So I don't want to use it there yet. I could just simply do a conditional render check. So just check if user is not null, display some loading or something. Then if the user has a value, then display username. But I don't want to do that yet. So now, cool. Our application is not breaking. The two places I would want to display this user would be in the nav bar and also in the footer. So let's head over to settings and do that. So in our settings component, what do? We pass in the second action. So what's going to be this action? We can just call it fetch user. And it's going to do what? Dispatch the action with type. Over here, it's going to dispatch this particular action. So our component is going to dispatch this action. Then our middleware would be in charge of calling this function that does all this asynchronous code. So I'm just going to copy this. In the next video, I'll show you would be reducing our copying and pasting and reduce all these boilerplates. But let's keep doing it from scratch for now. So over here, I want to map dispatch to prop. So I want to make this fetch user property available to our settings component. So whenever I load this component, I want to do what? Dispatch fetch user. So over here, I can now have access to fetch user. Then I can be able to make use of this, the use effect hook. So for my use effect hook, I'm just going to simply do what's called fetch user. And I'll pass this function as a dependency because of this exhaustive dependency stuff for ENSLIT. But just this is going to load our user whenever the components loads. So now, where do we want to display the user? We want to pass it over here. So let me just save, and we'll see the same error of name dot null is, am I? Okay, we won't see it yet because we've not mapped the state to props. So now in our reducer, I want to be able to do what? Have access to this user property. So that'll be very simple. In our map state to prop, we'll just say user should be state.user. Then we can save. Cool. We have the user. And the reason we are not seeing that error I just talked about was in our nav bar and in our footer. Let's head over to our footer. You can see I did this condition. So if the user is not null, display this. That's why we did not see that error. The same thing I also did for our nav bar. So you can see over here, we have access to this information. So one more thing would be to head over to Redux DevTools and you'd see what happens. So you can see, can you see the fetch user is being dispatched? So if I reload the page, can you see fetch user is being dispatched? Then if I successfully get the user, the second action is being dispatched. So you can see fetch user, then in fetch user success, the state updates. So you can see it over here. The state actually updates. So you see how we just achieved this using the ReduxSaga middleware. I hope this was explanatory. This was understandable for you guys. So once more, I could just do a brief recap. So first of all, I showed you guys this diagram of how your React Redux application flow works, whereby the component dispatches an action. The action gets to the reducer. The reducer checks the type and the data of the action, then updates the state accordingly, which is now sent to the store. Then this store now passes the value of the state as props to any component that subscribes to it. So the reason behind this video was to show you that you can't perform asynchronous actions or side effects. You can't do that in your action because your action is just simply an object. You can't do that in your reducer because one of the rules of Redux is that your reducer should be a pure function, which means it should not have any side effects. And I talked about some features of pure functions and why you should not have side effects inside your Redux function. I gave one example of race conditions whereby, for instance, now you try to fetch this user multiple times. Your reducer would not be able to know which of the returned requests it should use to update the store. So that's the disadvantage of one of the disadvantages of making this reducer not to be a pure function. Another disadvantage is, or another advantage of making it a pure function is testability and predictability. So for this example I gave you guys here, whereby this add function whereby this add function was a pure function initially, whereby whenever you pass 5 and 2, it always resolves to 7. But when we made this function to be impure and we passed in 2 and a random number, the function was not predictable. So for your Redux application, you need that predictability because you're going to be testing your reducer. So for instance here, if I pass in just flying and I click on update channel, you want your reducer to be very certain that once I click this button, it should give me flying and not any other value. So that is part of the advantages I just explained here. So we then talked about middlewares, whereby middlewares are in between your action and your reducer. So these middlewares can be able to do stuff like asynchronous tasks, logging out some information in between your action and your reducer, and some other things. But the one we focused on in this video was asynchronous tasks using ReduxSaga, where I also explained about generator functions. I showed you guys the normal functions that runs from start to finish without stopping, and I also showed you the generator function whereby it stops after it's, or whenever it returns the value being produced by this yield keyword over here. So you can see with generator function, you can be able to stop and play your function execution. So now you might say this code over here, why don't we do this with async await? You could actually do it with async await, but the advantage of using ReduxSaga is that you can actually cancel execution of the function. So if you can see over here, this effect over here, take every, there's another one called take latest, and from the name take latest, I could just do this. So what take latest does is very simple. It takes the latest call of this particular fetch user. We are not going to be able to see it here, but if this fetching of this user was a button and I had to click the button like 5 different times, what this take latest is going to do is that it is going to execute the last action I clicked. So it's going to execute the 5th click, while you have another one called take leading. I'm not gonna, but if you do it, take leading. So what take leading does is that if I replace it over here with take leading, what that means is that if I click on the button that's going to fetch this user, if I click on it 5 times, it is going to take only the first button click, which means it is going to execute the first action. So async await does not have some of all these stuffs I mentioned, especially canceling promises. You can't cancel your promises. You can't cancel promises. So, but with generators, you can be able to cancel the iteration. You can be able to cancel the execution anytime you want. And one more thing I imported here, I imported this call effect. And remember I told you guys that effects are just used to send instructions to your middleware. So this put effect, the instruction is sending to your middleware is what? An action. Dispatch this action with the corresponding data. So this other effect is the call effect, which is used to just dispatch, not dispatch, it's used to call asynchronous functions. So this is how you make use of it. So instead of having it this way, it's going to take what? The function name, which is axios.get, and the second one would be the parameter, the arguments of the function. So for when you're using this call effect, you have to separate them this way. So if I run this code, it should still give me the same result. So if you watch over here, you can see it gave me the same result. So you might be asking like, okay, what's the difference between this one and this one? The answer is very simple. So if you use this line number 7, if you actually call this stuff this way, it will be very hard to test because it executes a promise and returns a promise over here. But if you make use of this call effect, what it does is that it calls this particular function with the argument. So you can be able to test, you can be able to write your test easily when you execute this code this way. I know that explanation was crappy, but what that simply means is if you do it this way, it returns a promise. So if you are writing test for it, you have to mock your promise response. So if you've done a little bit of testing, you have to mock your promise response. But if you make use of this call, what you just have to do is that you write a simple test to say, okay, if something like this, if let me see, okay, if Saga, I'm just doing Saga dot next. Remember, the Saga is kind of like this Saga. This is a generator function, so it will have that next stuff. So if Saga dot next is equals to call with axios dot get and the parameter. So you can be able to like create a simple assert statement like this. So this is just rubbish code, but I'm just giving you an example because of this way we this format we did here. You can be able to say this saga.next, is it going to be this particular function that would be executed? You can be able to test. But if we don't do this now, what is going to be your value? It's going to be a promise, and you have to mock that promise. So we won't be going into that in this video, but I just use this to show you guys why this call can be actually useful. If you're not writing tests, you can use this particular first code and mock your data if you'd eventually write tests. But this is a very this is a better approach to write this. So after we created our Saga, what did we do? We updated our reducer to be able to update our store based on these actions. Then finally, we created our Saga middleware, applied the middleware as an enhancer to our store. Then we ran the Saga, and this Saga we are currently running is this particular Saga. So what this does is that whenever I execute fetch user, it should call this guy over here. So in our settings over here, I added the dispatch function fetch user, and I dispatch fetch user whenever this component loads. So I think that will be all for this video. Then in the next video, I would show you guys how to structure your app better and reduce all the boilerplates from this particular application. So I'll see you in the next one. Bye.